What I need to talk about now is two special types of tides, okay? Actually, I probably can fit this in another part of this page. Let's save some paper. Okay. Here we go. So, please don't be distracted by this cat. So, we said that the moon makes the tides happen with gravity, right? The moon makes the tides happen with gravity. Please stop biting me. Okay, 1 second, guys. Get out of here. Stop biting me. Stay. Please. Okay. All right. Okay. So, here we go. So, this right here, this is like that, I know this is in Zoom, but this is that Zoom bombing that everybody's talking about right here. This cat. Okay. Anyway, here we go. So, I'll cut all this out. I mean, not all of it. Cat's in the content. Okay, so, we said that the moon makes the tides happen using gravity. But is the moon the only thing that we feel a lot of gravity from? What's another thing that we feel a lot of gravity from, other than the moon? Actually, we feel more gravity from it. The sun. Okay, so we feel even more gravity from the sun than we do from the moon. Okay? And it turns out that the sun has a tiny effect on the sun has a tiny effect on the tides. Okay? Here's my next question. If we feel more gravity from the sun than we do from the moon, why is it that the moon has a bigger effect on the tides? Why does the moon affect the tides more than the sun does if we actually feel more gravity from the sun? It's closer. Yep, it's closer. That's correct. Because the moon is closer. Because remember this, the reason that everything got stretched out like this is because this side of the planet feels a lot more gravity than this side of the planet from the moon, right? And that's because the moon is close. Because the moon is close, the distance to this side of the planet is a lot less than the distance to this side of the planet from the moon. So that difference in gravity is what does it. But imagine that like the sun was just way, way, way over there. The sun's just way over there, for example. If the sun was way over there, 93 million miles away, then the distance from this side of the Earth to the sun and this side of the Earth to the sun is basically the same. So they feel about the same gravity. Because the sun is so far away, there's not a big difference in gravity, even though the total strength of the gravity is higher. So basically, the moon gets to decide where the tides are going to happen, and the sun's just going to give a tiny little extra pull on it, okay? So that means most of the time, we can't actually notice that the sun is having an effect on the tides. Most of the time, it's not really noticeable. But there are two special types of alignment that the sun and moon can be in to give us special tides, okay? And I think somebody has a question, so I'm going to go ahead and start drawing something real quick while that's coming out, and I'll check it for the question in a second. So let's say that the Earth is right here. Put an E on it. And let's say that the sun is way over here. Now, if, oh, that's okay. It's okay. All right. Now, so if there was no moon at all, and the sun was right here, where would it want the high tides to be on the Earth? Would this sun being right here want the high tides to be on the top and bottom, or left and right? Where would this sun want those tides to be? Top and bottom of the Earth, or left and right? Remember, it's all about the pull of the gravity. Yeah, left and right, okay? So if the sun was right here, it would want the high tides to be towards and away from it, just like the moon likes the high tides to be towards and away from it, okay? So that's correct. Now, oh, you're going to freeze on me again? I hate this machine so much. Okay, sorry, we're back. Now, so here we go. If we wanted the sun and the moon to work together, the moon could be right here. If the moon was right here, then the moon would also want the high tides to be in the same place that the sun does. You can see that they would pull together here. What would that do to the high tides? On that particular day, if the sun and the moon were lined up like that, what would happen to the high tides on that day? They'd be a bit higher. Not a crazy amount higher, but a noticeable amount higher, okay? So the high tides would be extra high. Okay? But it's a little bit hard to tell, but you'd also be able to have those extra high tides if the moon was over here. Now, it seems like the sun and the moon would be working against each other right here, but they still would want the tides to be in the same place. So if the moon is here or the moon is here, we have a higher than usual high tide called a spring tide. So if the moon and the sun work together, we get spring tides. Okay? So whenever the moon is here or here, you get a spring tide, extra high tide. Okay, here's my question. When do spring tides happen? When do spring tides happen? How often do we have them? Take a guess. And I'm trying to trick you here. I'm trying to trick you. Okay. So here's the thing. This was a trick question. Oh, and somebody got the right answer. Okay, that's very good. That's very, very good. So the name being springtide tricks people into thinking these only happen in spring, okay? But it's not going to happen just in spring. I'll explain the name in a second. It happens twice a month. Twice a lunar cycle, twice a moon phase cycle. You actually get spring tides every time the moon is here and here. And these are certain tides. Somebody actually said it already. That's a new moon and a full moon, okay? How do we know that this is a new moon right here? How do we know that this is a new moon? What's special about where the moon is? How can we always tell where new moons are? When the moon is... Yeah, that's basically what I'm getting at. When the moon is between the Earth and the sun, then it's going to be a new moon. So every single new moon gives us a spring tide, and this is the moon when it's on the opposite side of the planet. So every single full moon is also going to give us a spring tide. So why do we call it a spring tide if it doesn't just happen in spring? Well, check it out. Words have multiple meanings, right? Words have more than one meaning. This is not spring as in like birds tweeting, like tweet, 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 spring, right? Why is this called spring? It's another meaning. Is a spring, right? It's like a boing. It's sprung up. The water has sprung up in a spring tide, okay? So, here we go. You're going to have to stop bothering me. Okay. Now, okay, so every single full moon and new moon gives us a specially high tide. Okay, now, on the other hand, what if the sun and the moon work against each other? If we put the sun in the same place and the Earth in the same place, remember we said that here the sun would want the tides to be on the left and right of this Earth, where would the moon need to be in this picture to fight what the sun wants? Where would the moon need to be in this picture? Up on top, that would work. And there's one other place. Where else could the moon be? On the bottom, right? So if the moon makes sort of an L shape or a right angle with the sun, then it's going to be perfectly working against what the sun wants. Okay. And who wins? Who wins on getting to decide where the tides are going to... Let me put it this way. If the moon wins, the tides would be on the top and the bottom here. If the sun wins, they'll be on the left and the right. So who wins? The moon. The moon has a bigger effect on the tides because it's closer. So we're going to have a high tide here and here. But what are those high tides going to be like? What are those high tides going to be like compared to a regular high tide? Yeah, exactly. Not as good, right? They're going to be not as high. Okay. This situation is called a neap tide, and it's the last tide we're going to talk about. Neap tide. It basically means a weak tide. Okay, it means a very weak tide. So our high tides are kind of It's still a high tide, but it's going to be, a few inches lower than usual. All right. Now, last thing I want to ask about this. Can we figure out what moon phases would give us neap tides? When the sun and the moon are at right angles, you might have to look on your moon phase figure. Which phases are going to give us neap tides? We bring in our moon phase figure. If the sun is over here, right, the Earth is here, we're talking about this phase and this phase. Yeah, that's your first and third quarter. So every single time we have a quarter moon, we're going to have weak high tides. And every time we have a full or new moon, we're going to have strong tides. Okay? And actually, one cool thing about that, in a spring tide, if our high tides are higher, then that means the low tides are also lower, right? And a lot of animals have learned to use this. Like there's a species of land turtle. I guess it's a tortoise. I don't really know. I'm not a biologist, but there's a species of turtle that lives on the land that likes to eat clams or other shellfish. And those grow on the bottom of lakes. And those turtles actually know that if there's a full moon out, there's going to be a spring tide today. And that means if they wait for low tide on that day, the water will get extra low. And it'll be easier for them to get to the shellfish that they want to eat, right? So, they probably don't know why they're doing it, but there's animals that know to use the full moon to use the effect on the tides as part of their life cycle. I think that's pretty cool.